Jackie with DMT Institute, and today we're going to talk about equivalent fractions. Before we get into this video, though, I do want to reference a few things that hopefully students have experienced prior to this more formal look that we're going to take at equivalent fractions. One of which, and probably the most important, is just the understanding of what a fraction is and really having a chance to develop that fraction language. So if you haven't watched the video that Jonathan did on fraction language, you're going to want to go back and watch that first, just because we're going to use that language all the way through to talk about equivalent fractions. The other thing that hopefully students have experienced is just the opportunity to see equivalent fractions visually. Even seeing that 1/2 and 2/4 land at the same spot on a number line, or look at them in a bar model or other visual representations, is going to help with the conversations that we want to have with them here. All right, so for this, we're going to start with the fraction 3/4, and you can see that fraction language up in the corner for us to reference as we go through this. So we've taken our bar model, partitioned it into fourths, and then shaded 3 of those 1/4 units. And what we're going to do is we are going to take those 1/4 and we are going to partition them in half. So now we've got to figure out how we're going to label these new units. And if students are struggling with that, we can go back to that fraction language again and talk about, well, how many of these smaller units would it take to compose 1? Which will hopefully have them count. See, it's 8 units. So now if there's 8 to compose 1, it means they're going to be 8s. So we can go ahead and label those 1/8. Now we might ask students another way that we could now name this shaded area. So before we were calling it 3/4, but now we can see we can also call it 6/8. So we're going to talk about some things that are changing and some things that are staying the same as we go from calling it 3/4 to 6/8. All right, so let's start with what's staying the same. And oftentimes when we're talking about equivalent fractions or equivalence, that's what we're talking about, is we're talking about the things that are staying the same. So in this case, one of the things that's staying the same is that shaded area. We didn't shade anymore. We didn't erase any shading. We still have the same amount of that bar model shaded. It just looks different. And we also have our same unit of 1. That's another important thing that we have to make sure that we have if we're going to talk about equivalence, that we're referring to the same unit of 1 when I say that 3/4 and 6/8 are equivalent. But we're going to take a minute and talk about what's changing. Because a lot of these ideas that we can talk about with what's changing are going to help students later as they start to think about multiplying by a fraction as a scalar, is that idea coming up later. All right, so let's start with what happened to the unit size. So the size, and again, go back to when we made those partitions, the size got half as big. So I went from looking at these 1/4 units to looking at our 1/8 units, which are half as big as they were. But in that same moment that I made the pieces half as big, or the units half as big, now I have twice as many units to compose 1. So those two things happen simultaneously. Really why we need both of them when we talk about the denominator. Then we can look at the count. So before I was counting 3 units, and now I'm counting 6. So I'm counting twice as many units as I was. Well, but that also goes back to the size of the unit. So if it's a smaller piece, if it's half as big, I would have to count twice as many to get back to where I was, or to compose that shaded area. So now let's take a look at that more formal equation that we sometimes see with this. So if I take a look at my 3/4 and I multiply it by 2/2, we're going to start with the denominator. So this 2 in the denominator takes my fourths and partitions them in half, which takes care of these two things. It makes that unit size half as big as it was, which then creates twice as many units to compose 1. This 2 in the numerator doubles the count. And again, I have to double the count because those unit sizes are smaller. So when we think about equivalent fractions, it's important to talk about, again, not only the things that are staying the same, but also those things that change. Again, just to highlight some ideas that are going to help kids later. All right, so I hope that was helpful. There's some practice pages that you can use to work on this skill and help model some and practice that language. And we will see you next time. Thanks.